under the context of normal distribution, there's one more important type of chart that you should be able to read. We're not going to make it, but they're called normal quantile plots or QQ plots. I personally prefer QQ because it's kind of fun to say. And if you are a gamer or kind of are familiar with what QQ means, well, I'll let you look it up. But anyway, the idea with a normal quantile plot or a QQ plot is that it's a plot where you plot the z-score of the percentile of the observation. Okay, they call it the theoretical quantile. Okay, not to be confused with quartile. Quantile and quartile are different. The z-score of the percentile of the observation, theoretical, versus the observation itself in a so you list the observation based on its percentile. Okay, that's why they call it quartile or quantile. Again, you could interchange quantile with percentile and it means the same thing. So the percent of data that is below that observation. Okay, and so this is what a typical QQ plot would look like. This along the vertical axis, this is your sample quantile. Okay, your sample percentile. So for given data or given observation, what percent of the data is below it? And then down here, this is your theoretical. Okay, so this is your sample quantile on a z-score, as a z-score, but expressed as a percentile. Okay, so theoretical quantile. Okay, now we're not asking you to produce it. It's amazingly difficult to produce this using Excel. Other softwares can produce it in a heartbeat. I don't know why Excel can't. What we need you to be able to do is to analyze it, okay, or interpret it, okay, and here's the interpretation, okay. If the observations follow roughly a 45-degree line, so think of the line y is equal to x, okay, roughly, okay, then we're going to say it's normally distributed. Okay, if it differs from the line in a systematic way, like if the pattern shifts as a whole, then we're going to say that there's non-normal behavior. You could have, so this one, it's maybe not normal precisely, but it's pretty darn close. Okay, so this one, I would be tempted to say it's approximately normal, not that it is normal. If you have, an observation out here that's, far from that, I wouldn't say that the pattern changes. I would still say that it is normal. I would just say this one is your outlier, or a suspected outlier that we have to prove is an outlier later on. But you can have outliers and still have a normal distribution. Okay, so what that means is if by looking at the QQ plot, we can say it's approximately normal. Okay, so if we looked at the data in a different way, perhaps a histogram, okay, in the histogram, right, we would see bars that are approximately normal in their shape if we were to connect them. Okay, so that's what we would see. Okay, so with that idea in mind, I'm curious what you might say about the normality or about the data sets depicted here. So the red line is your 45-degree line. Okay. What can we say about each of these? Are they normal or non-normal? Okay, well, the first one, I think you can say, okay, that follows the line, so this is normal. Okay. This one is, well, not normal, even though they kind of balance each other out, not normal. And this one definitely is not normal. Okay. Now, if you were to envision the histograms that match to each one of these, it's kind of interesting to think about it. So the first one, I mean, normal would look something like that. For the second one, what we see is that, okay, if we think of this as the tipping point and kind of the mean, right? So I'm just going to draw a little teeny tiny sketch. So we have a mean, right? But then we have values that are significantly below it, like they're quantiles, or they're, in theory, they should be, they're lower than what we would expect them to be. After that tipping point, though, there's a lot of values that have a seemingly low sample quantile. So in the data set, there's a lot of values kind of clustered around the extreme values that are small, and similarly above. So we would see something that is more along like this sort of behavior. We would call this, in statistics, we would call that a uniform-ish distribution. Well, ish is not technical. It's technically a uniform distribution is the name. So it's something that's relatively flat across all the way. This other one, this is very not normal, and this is actually more in line with what we would see in an exponential distribution. So we would see, in this case, we have the sample quantile being small. There's a lot of values that occupy. Let me rephrase. There are many observations that are smaller than what we would expect, and so consequently, when we think about a histogram, what we would see is something more like this. So it is skewed to the right because there are less frequent values off to the right side. Okay, so this one looks more exponential in nature, at least when you're looking at the QQ plot, but then that skew is actually a right skew. Okay, so high level, we're mainly concerned with, can you say it's normal and not normal? Histogram is kind of an added bonus. It's a bit of an extra step that is not necessary, or that is not necessary for any exam, but it could be interesting for you to think about. And so on that note, there is an Excel, or there is an extra file for you available where you can match each histogram with its QQ plot. Okay, so I will give you one answer, and that is these two match. Okay, so the normal thing that's approximately following the line looks like a normal curve. Okay, that one you probably could have got on your own. But then can you connect the remaining QQ plots to their histograms? Okay, so take a shot at it on your own time. This is a bit of an extension activity for fun and enjoy. Okay, so that's going to wrap up our normal quantile plot discussion and the whole section on normal distributions.